In this lesson we will be discussing two resistors in parallel and a third resistor in series. In the circuit diagram shown, two resistors are in parallel with a third in series. The equivalent resistance of R2 and R3 is R2 times R3 divided by R2 plus R3. And since the third resistor R1 is in series with the parallel combination of R2 and R3, the total equivalent resistance in the circuit can be expressed by RT equals R1 plus R2 times R3 divided by R2 plus R3, or R1 times R2 plus R1 times R3 plus R2 times R3 divided by R2 plus R3. The total current I drawn from the voltage source is given by E divided by RT, or E times the quantity R2 plus R3 divided by R1 times R2 plus R1 times R3 plus R2 times R3. Using the current division rule, we find that I1 equals I times R3 divided by R2 plus R3, and I2 equals I times R2 divided by R2 plus R3. Knowing that I is equal to I1 plus I2, we get I2 equal to I minus I1, which equals V3 divided by R3 and V2 divided by R3, since we know that V3 equals V2. And I1 is equal to I minus I2, or V2 divided by R2, and is equal to V3 divided by R2. Since V1 equals I1 times R1, using the voltage division rule, we get V1 equals E times R1 divided by RT, and V2 equals V3, or I1 times R2, which is also equal to I2 times R3. Therefore, V2 is equal to E times the equivalent resistance divided by the total resistance, or E times R2 times R1 divided by R1 times R2 plus R1 times R3 plus R2 times R3. The total power from the source is the sum of the individual powers dissipated. Thus, P is equal to P1 plus P2 plus P3. Using the diagram shown, find the values of RT, I, I1, I2, V2, V3, P2, P3, and P. Solve first for the total resistance. The total resistance is equal to R1 times R2 plus R1 times R3 plus R2 times R3 divided by R2 plus R3, or 250 times 300 plus 250 times 450 plus 300 times 450 divided by 300 plus 450, or 430 ohms. Next, find the total current using the following equations. I is equal to E divided by RT, which is equal to 12 volts divided by 430 ohms, or 0.028 amps, which is equal to 28 milliamps. I1 is equal to I times R3 divided by the quantity R2 plus R3, or 28 times 10 to the minus third amps times 450 divided by 750, or 16.8 milliamps. I2 is therefore equal to I minus I1, or 28 minus 16.8, which is equal to 11.2 milliamps. We can now find V1, V2, and V3. V1 equals I times R1, or 28 times 250 times 10 to the minus third, or 7 volts. V2 is equal to I1 times R2, or 16.8 times 10 to the minus 3 times 300, or approximately 5 volts. V3 is equal to I2 times I3, which is equal to 11.2 times 10 to the minus 3 times 450, or approximately 5 volts. This was expected since we know that V2 is equal to V3. Finally, we calculate P1, P2, and P3, the power dissipated by R1, R2, and R3 respectively, as follows. P2 is equal to I1 times V2, or 16.8 times 10 to the minus third times 5, or 84 milliwatts. P3 is equal to I2 times V3, or 11.2 times 10 to the minus third times 5, or 56 milliwatts. To find the total power delivered by the source, we must also find P1. P1 is equal to V1 times I1, or 7 times 28 times 10 to the minus third, or 196 watts. Hence, P is equal to P1 plus P2 plus P3, or 196 plus 84 plus 56 equals 336 milliwatts, or P is equal to 0.34 watts.